Hello everyone and welcome to the Dragon Code. In this video we are going to work with Lidar in Python. So let's start. Code for listening Lidar and converting raw data into angle dot points is already written in GitHub repository. This here is official GitHub page of Lidar. Link is down below in the description. From here you should go to this GitHub profile. Here you should select Python repository and download or clone this repository. Here you have explanation of code and how to use it. After downloading repository, open it in VS Code. Here you have files for listening data and calculating data. Now I will add another file. I will call it Lidar. Here I will copy code from repository's readme file. And one more thing, here I will change name of port. In my case it is COM5. You should check it in device manager. You can do it like this. Go here, device manager, and here in ports you can see in my case it is COM5. Now I will go back to Lidar file and run this code. You can see this is array of angle dot points. Now I'm going to visualize these points and I will do it in several steps. First I will create another Python file, functions. Here I will import NumPy, library and math. I prepared those functions and here I will just paste them. And I will add alias here and p. So, first step is to convert angle dot points in Cartesian points, which have x and y value, and they can be represented in coordinate system. It will be done in this function process Lidar data. I will pass angle dot points, and each angle dot point will be converted to the Cartesian point. Angle will be converted from degrees to radians, and this formula for x and y. After that, I will create grid. It will actually be two-dimensional array with zeros and ones. 1 will represent free space and 0 will represent space with obstacle. X and Y values of each dots will correspond to row and column indexes in grid. But there's one more thing you need to be careful about creating grid is that array cannot have negative indexes. So I need to translate these dots. To do that, I first need to find minimum x and minimum y. And then for each dot I need to subtract x value with minimum x and y value with minimum y. It will make all values positive. Then I will create NumPy array of all ones. And then if there's obstacle, I will make that grid item 0. Now I can go to Lidar Python file. I won't print those dots. I will include this file functions sf. Then I will convert angle distance dots to Cartesian dots. I will use process lidar data and pass this. I'll also make this list numpy array. I need to include numpy library, numpy module. In Python it is module snp np array, and then I will create grid map from Cartesian dots. And let's now print Cartesian points, Cartesian dots, and grid. Here you can see it is grid with zeros and ones. And last step is to visualize that grid. For that I will use module matplotlib. So import matplotlib, and from that module I will use pyplot splt. I prepared code for that. Here I need to pass grid. And now let's run this code. And here you can see how my room looks like. Where are obstacles? This here is wall. This is top of bed. This is curtain, and so on. And now it's time to compare my visualization with software of Lidar. Here in software is degrees are little inverted, but you can see that is same room shape. This part is here, this part is here, and this part is here. Again, this is curtain, this is top of bed, this is wall. This is all for this video. If you like this video and want more videos like this, press like button and subscribe, and see you next time.